Hey guys, I hope everybody's doing well and that you're getting your homework done. And if you need any help at all, just let me know. Contact me through Gmail or on Facebook, or you can send me a message if you want me to call, or I can do example problems for you. Earlier this week, I asked you guys about the corgi puppy and how do we get a blue corgi. So kind of as a refresher, I'm going to walk you through what we learned back in genetics in Bio 1. So what we have is we have two red corgis. Now red is the dominant trait, so it's going to be either two capital letters or a capital and a lowercase. To get a black-headed tri, you're going to have two lowercase letters. So then how do we get a black colored corgi when you have two reds as parents? Well, if they are both heterozygous, you get this 25% chance that you could have a black-headed tri corgi. So where does blue fit into all this though? So a recessive point mutation is what caused this pigment coloration to begin with. So an example of that would be if your DNA read ATT, you could mutate to ATC and this is on a different gene that codes for pigment, and then you get this blue color. It is recessive, so to get that lighter blue color, you have to have two lowercase letters here. If you have two capitals or a capital and a lowercase, you get a normal pigment. So this is where we get that dreaded big square. All right, so since we're looking at two different genes and two different things here, we've got two letters, which means that I just need to know how many combinations can I get. So I'm going to take this capital A and that capital B, and that might be one of the gametes or one of the egg or sperm. I'm going to take the capital A with the lowercase b, and then I'm going to do the same thing with that lowercase a. I'm just going to do all my possible combinations. Now this is just, for instance, if each parent were heterozygous for both traits. So that's what we've done. So the parents are going to have the same. So I'm going to put one on top, one on the side here. And if you fill your square in, I've color-coded what you would get. Two capital A's means it's going to be a red corgi. Okay, if you look down here, my two lowercase means it's going to be black. The B's, though, tell me if I have complete pigment or color for the pigments or if I have that lighter color. So if I have two lowercase b's, I'm going to be a lighter red. And you can have that light red. They're considered like a bluey red. So you have three of those possible puppies. To get the blue, the black that is also a blue, you have a 1 in 16 chance of this happening. Now, this is only in the case where both parents are heterozygous for both traits. So you would actually have two red parents that do not show this color, this lighter color at all. But they could have some puppies mixed in there and you wouldn't even know that's going to happen. So what you end up getting is 9 out of 16 puppies on average would be red with the normal pigment. 3 out of 16 would be red with that lighter colored pigment. 3 out of 16 would be black with the normal pigment. And then the 1 out of 16 would be that blue color. So once again, just if you had two heterozygous. All right, so if you had a parent that was a blue that actually looked like this, then that would change your results up quite a bit. So anyways, that is all I have for you guys for genetics. I will come back at you with some chemistry stuff here later in the week. Thank you. Bye.